Hello and welcome to Lecture 5 on JavaScript in this semester's edition of Web Engineering. JavaScript is a way of introducing interactivity in the browser. So far we have heard about how to use HTTP and then HTML and CSS within the browser. We knew how the browser works. Now we're going to talk about one very important component that is part of the experience of a website or a web application, namely introducing dynamic aspects or interactive aspects into your site or application. And as part of the lecture today, we're going to talk about three things. First, we're going to talk about the core language constructs of the language JavaScript. We're going to talk about the common APIs and the standard library, so to speak, of interacting with JavaScript in the browser. And lastly, we're going to talk about event-driven and asynchronous programming in the browser. What I want you to get away today is I want you to become proficient in building dynamic client-side functionality with JavaScript, client-side meaning in the browser. I want you to be able to interact with and understand common APIs in the browser that are important during the lifecycle of an application, specifically the document object model, the browser object model, how to use HTTP, APIs, and local storage. And lastly, again, I want you to understand how the asynchronous nature of JavaScript itself in the browser works and how you deal with event-driven programming. So let us get started with the core language itself. JavaScript is an interpreted scripting language, meaning that it's not compiled. When the browser, specifically in our case, reads the language, it interprets the language and executes it within a virtual machine in the browser. It was originally developed by Netscape very early on in 1995, but it's seen a lot of development over the years. And it's now standardized as the ECMAScript language. And there are other ECMAScript implementations, but we're looking at JavaScript in this course in general. And the focus on this course is specifically on the newest standard of ECMAScript, namely ECMAScript 6. And now there are many different ways of integrating your JavaScript into HTML. I would say the standard way is in your head tag in HTML, you introduce a script element. And you can see an example down here. The script element can be of type text JavaScript, and then you can introduce your JavaScript code within within this tag. You can also include an external script, as you see on the right here. You can say, again, script type text JavaScript, and then you say source, and then you provide a file that you want to introduce within the HTML. Now, the defer option you see there, that is something fairly new. Before that defer option was the case, what happened was that as soon as you introduced JavaScript, the JavaScript was executed. But that was not the functionality that you actually wanted from your JavaScript. Oftentimes, the JavaScript that you had interacted with the site itself. But if you had the JavaScript included in the head, then oftentimes what happened in the body was not yet rendered and was not yet available for the JavaScript to interact with. And that was a source of many errors. So what people did is they loaded their JavaScript when the page was loaded, so they attached it to an event, or they put their JavaScript all the way to the bottom of the body. And so those were all things that language designers did not intend for JavaScript to be. So they introduced this new feature called defer, meaning that you can put your JavaScript script tag wherever you want, and it will only be executed when the page is loaded. So it's going to defer loading the JavaScript until the page load is completed. And then we have another possibility of introducing JavaScript with a type module. We're going to go into that a bit later in the session. Yes, so I think this is already what we've been talking about. Oh yeah, and the type module is defer by default. And now, if you've done the pre-reading / pre-doing, you know most of these things here, but I'm going to go over them quickly anyway. So JavaScript is a dynamically typed language, meaning that you don't have to specify a type when you're defining variables. So you define variables by a few keywords. I'm going to go into that a bit later, but as soon as you assign a value, then JavaScript will infer a type for that variable. So as you see on the right side here, if we assign a true value, it becomes a Boolean object. If we assign a string object, it becomes a string, and so on and so forth. And a more complex data type that you have in JavaScript is the concept of an object. And objects, you may have heard from object-oriented programming, it's a bit different from there because objects in JavaScript don't have an underlying class, so to speak. Objects are associative arrays or dictionaries in other languages. And then another core construct in JavaScript that we're going to talk about at the end of this lecture in more detail are events. So a lot of times when you want to interact with or introduce JavaScript, you do so by having events that you react to. So in this example on the right side here, you may see that you have an image and then this image has an onClick event, and in there you can already have JavaScript code that happens. However, this way of introducing JavaScript is not something that you want to do for your production code. This is something you want to do maybe for testing certain aspects of your JavaScript and of your events. But eventually you want to separate the markup, as you see here, the image tag, from the actual dynamic behavior. And here is an overview of the types you might have in JavaScript. So in order to introduce a variable, you use these three keywords, var, const, or let. We're going to go into more detail into what those mean. But for now, let's just assume you use let, you give a name and a value. So let's actually try this out in the console. So what I'm using here is, this is the Node console, and here I can type in any sort of JavaScript code. So I might say const x equals and then 7. Okay, and now if I say type of 7, this is going to be a number. All right. And now because I use const, I cannot reintroduce the variable again, right? The variable cannot change anymore. If I want to say x equals 8, it will tell me, well, it's a constant variable. Now if I use let on the other hand, let's say let y equals, let's say true, right? And I say type of y, then that's a type of Boolean. Now, but if I say y equals 8, then I can do that. So I can change the type of my variable on the fly if I have a let declaration, for instance. And I can do that again. I can say, well, let equals actually something else, right? And now y is a string variable. If I say type of y, you will see it's going to be a string. Okay, and the literals we have within variables in JavaScript are, the most common ones are number, string, Boolean. Then we have the more complex types, namely array and object. And the interesting thing with JavaScript is, and we're going to go into that in a couple slides, functions in themselves are also literals. They can be values that you pass around. And then there are two special values. One is null, that you can definitely assign, and one is undefined. And let's quickly go back and look at that also. If I say let x, okay, let z in that case, then z is of type undefined, but its value is undefined, right? So this is a special case of value. I can assign it a null value, say x z equals null, and then the type is an object, so it's a different type. And then the other interesting thing is comparison. Now comparison has been a source of, let's say, interesting errors in JavaScript. So in the next slide, we're going to go through a bit of the pitfalls that people go through when comparing different variables or different values within JavaScript. So one thing I want to point out, so there are also like actual type conversion functions. So if you use a plus, for instance, in front of a string, it will convert it into a number. If you use parseInt as a function, it will convert a string into an integer representation or number representation. If you use toString, it will try to make any other construct into a string. Okay, and just for you to know, any non-empty values are considered to be true. So 0, the empty string, and null are still true. So if you say if empty string, it will come out as true, for instance. Only if it's something's undefined, it's actually false. And the other thing is that type conversions often happen automatically. So that's also, and you see that on the right side here. So if we do 10 plus 5 as integers, that's 15, that we know that. So if we do 10 plus 5 and 5 being a string, what it does is it will convert the 10 into a string and then concatenate those two things together. And that happens because plus is not only the addition for numbers, it's also the concatenation operation for strings. And the same thing happens for, the other way around, it happens for the multiplication operator. 10 times 5, 5 being a string in this case, 5 will be turned into a number, and then we'll actually do the multiplication. So just be aware of those things in JavaScript. Type conversions just happen automatically. And then the operators that you have in JavaScript are the ones that you expect. You have addition, subtraction, multiplication, division. You have plus plus as an increment, minus minus as a decrement on a variable. So, and then you have percent as a modulo operator. Now, the comparison operators are also the ones you might expect, but then you have two different equals operators. You have equals equals, and then you have equals equals equals. Okay, and the difference between the two is that if you use two equal signs, the one equality operator that you might have seen in different programming languages, what JavaScript will do is it will do type conversion first. It will try to match the variable as much as possible. So let's have an example on that. So if you say 7 equals equals string 7 with two equals, this will be true. However, if you use 3 equals, then type conversion will not take place. And now string 7 obviously is not equals to number 7. Okay, so it really depends on what you want from your programming language. However, I would suggest that especially in the beginning, you use the 3 equal signs, because that's the one that you mostly want from your equals operators. Now we come to more complex data structures. The one is the array, and the array is a heterogeneous list, meaning that the type of the array has not to be the same all over. So if you look at the right side, you see how the API or examples of the API of the array, and in this case I have a float in there, I have an integer in there. But if we just go through an example here, let's say I want to have a equals, and then I can have numbers, but I can also have some string in here. I can also have a float in here, right? And that's what I have. Okay. Now let's say I want to push a Boolean value on here, and as you can see here, and that's interesting, if you say push, it will add the element at the end of the list, and the return value of the push is the new length of the list. To have the length of the list, you can say a.length. You will get also the length. And oh yeah, and if you want to join together certain the elements here, you can say a.join, and then let's say you want to join by pipe, okay, and it will create a string separated with the delimiter that you specified, and it will turn your representations that you have here. In this case, you have a number. It will turn them into the string representation. So let's say you push onto the array another array to true. Okay, then now you have 6 elements, and now you have an array within the array. So that's also possible. Now, if we say the same thing again, we say a.join, okay? In this case, even though you have another array in there, see, it will turn this array into its string representation. And the string representation is just the elements in the array, comma separated, Okay, so just be aware of this difference here. Okay. Oh yeah, and so one more thing, certain array functions change the structure of the array and others don't. So just go, maybe as a kind of a homework, go through all these operations and see which one of those actually changed the underlying array and which one created a new array. Now, objects are, I would say, the most interesting data structure you might have in JavaScript. If you have used Python before, you know this structure as dictionaries. If you've used other languages before, you might have heard about them as associative arrays. And what objects are able to do is they allow you to provide key value pairs of variables in the structure, and it supports dynamically adding and deleting values. And the other complex thing that happens here is it supports having functions. So because values in JavaScript can be functions, the key in an object can point to a function. So if you see on the right side here, I can say x.func equals, and then I can provide a function that does certain things. And if you look at the example on the right, it might look familiar because JSON, something that you have definitely heard before, and you've seen at the course of this lecture series also, stands for JavaScript Object Notation. It means that before JSON existed, JavaScript existed, and because of the way that objects looked like, people started using that object notation as a serialized way of exchanging information. So serialized JavaScript objects are what JSON actually are. And that's why we internally in JavaScript have those two functions. The one is JSON.stringify. It takes an object and provides you with a string representation, a JSON representation of that object. And on the dual side of this, we have the parse function that you provide an object and then you get a JavaScript object from it. And there's one limitation to this. If you have a function within your object, you cannot serialize or deserialize it. So that doesn't work. And then we have something called template literals. And this is part of the string definition of JavaScript. So strings in JavaScript, and we've seen before, you use either double quotes or single quotes. You use the backslash to escape those quotes within the string. You can concatenate the string with a plus, but you actually shouldn't anymore. A quite recent development in JavaScript are those things called template literals or template strings. You use back quotes as a delimiter, and you can then have expressions starting with dollar and then the curly brackets. And within those dollar curly brackets, you can have any expression. On the right side here, we have, for instance, an object student with a key name that we're evaluating here. But the other example is that you can evaluate this expression here. GPA student means you're calling a function with an object student. So let's actually go through this and say, well, we still have this A here. Let's say we want to have, oh, by the way, you can access the array with indices, right? So you can say A0 and you can get the first element, and you can say A4 and you get the fifth element. Okay, but now let's go back to template. So template literal start with this backtick. You can say hi, and then let's just take something from the array, or actually let's just say we have a student object. Student has a name. I might already have a student within this session. Let me see. I think I have a student in this session. So S1, no, it's not defined. So let's define a student, S1, and the student has a name, and the student has some grades. Let's list, let's say 1, 1, 2, 2, 3. And let's say the student has a number, as in Matrikelnummer. Okay. Now we have this object called S1. It's, what happens? So I may have, oh, okay. So I introduced a syntax error here because I'm working with too many languages. So if you want to define a key value pair, it's not key equals the value, it's key colon the value. Okay, and now we actually have the object as one. Okay, so now if we want to say, we want to have a template literal, we can say hi, and then we say dollar s1.name. Your grades are s1.grades. All right, and then backtick again. Okay, and we actually get this string. Now, what you can also do is you can actually have expressions in here. You can say, let's say we can have, I don't want to do anything weird, but let's say I just want to get this, just some random computation. I'm going to get the first element of this grades, and I'm going to add 45 to it. 42 is actually the answer always. And when I do that, it actually does computation. So it takes the first element of this array and it adds 42. What I want to show you here is that within within the dollar curly brackets, you can have any sort of expression in JavaScript. It doesn't have to be just one value. Okay, now we come to the control structures you have in JavaScript, and those are fairly standard if you've worked with a language like any imperative language before, but especially if you worked with C or Java before, this might seem familiar because the syntax is very familiar. Obviously, you have an if, and then you have an expression that evaluates the true or false. If it evaluates the true, you get into the first branch. If it evaluates the false, you get into the second branch. Then you have a switch case. It's the same as if, just a bit of a different syntax, meaning that you go and compare different values of A in this case, and just be aware that this uses strict comparison. So it uses a 3 equal sign comparison. Then we have a for loop, and now we have 2 for loops in JavaScript. The first I'm going to talk about is the for off loop. What for off does is it loops through the values of an iterable object. An iterable object is an object that returns an iterator. In this case, an array is an iterable object, and it lets you iterate over all the values of the array. And compare this to the for in loop. What for in does is it iterates over the indices of an object, in this case the array. So if you look at the example here, if you use for in this example, it will return the indices to you and not the values. And now the regular for loop that you might have seen before in C or Java is the one we have here on the bottom left. You say for, and then you initialize a variable, then you have a condition when to stop the loop, and then you have usually an incrementer or decrementer at the end. And you can also use for in with objects to iterate over object keys. So if you use for in for an object, you will go through all the keys of the object. Okay. And then you have the while loops that you probably know. You have while, and then you have a condition, and then you have a do while loop that executes the statement body at least once, and then checks the condition at the end. So I think these are fairly standard. What I've also shown in this slide is debug messages. So if you want to debug certain things, especially in your browser, you can use this thing called console log, and then it will print on your console. And if you use alert, it will actually alert in the browser. So let me show you an example of this. So let's say I go to the browser, and now here we're in Tuvel, and let's go developer tools. And here I can also, in the console, I can also execute any sort of JavaScript. So this is the same thing you've seen before here. I can also do here. Let's increase the size of this a little bit. So what I can say here is, let x equals 7, and then, right. So it's the same kind of redevelop print loop called a REPL. And what you can also do here is I can say alert, and let's say alert, what's up? So I've already done that before, and then it will create this pop-up box for you. Okay. You can also say console.log and some message, right? And it will log this message on here for you. Well, it seems silly to do this here now. Let's imagine you have a loop somewhere, or you do something within an event, then you might want to see this. Okay. Okay, so we went through control structures. Now we're going to go through functions. And functions in JavaScript are declared with this keyword function. They can have arguments. However, the arguments don't have predefined types. They can have a return value. However, again, the return value does not have a predefined type. And the match of the function is only by name, not by parameters. So there's no such thing as function overloading. So let's have a look at an example here. This is a regular addition that takes a parameter a and b and returns a plus b. An example I show you here is that you cannot specify the types, meaning that people can pass on whatever they pass on, right? And if you say addition in this case with two strings, it will just concatenate those two strings. So the only way you can actually check for the types is by having a sort of a precondition that says, well, it has to be a number. So if you have a look at how this would look like is if you have a, let's say function add, and we have a and b, right? Let's lower this up here. And now if we say if type of a, let's stick with a, not equals number, right? If it's not a number, then just don't do it. Or let's not restrict ourselves. Let's just say we want to just return nothing as soon as the type is a string. If type of a is string, or type of b is a string, right? Whoops. There's no or, obviously. Okay, so let's go back. Again, happens if you program in too many languages. So or is those two things here, same as in Java or C. Okay, and if that happens, just return nothing, right? However, anything else, return a plus b. Okay, and now as we call add with string, right? This will return nothing. However, as soon as we have any other type, it'll just return the addition. Okay, so this is the only way you can actually enforce any type safety in JavaScript itself. There are new languages that transpile to JavaScript, things like TypeScript, for instance, that have a stronger type system you can use. Okay. The other thing is that if you leave out one of the elements, you will still be able to call the function. So if you say addition just with 7, however, what happens is that the variable b in this case becomes undefined. And so this is another thing that you have to check then. You have to check whether something is undefined. However, within ES6, there's something new. So if you look at the example to the right here, the second function, top grade, specifies a default variable, meaning that if threshold is not passed, it will set the default for the threshold to 1.5. Okay, and before ES6 and optional parameters, what people have done is they check whether or not the threshold is undefined and then set the variable to a certain thing. So this is the same thing happening here. So if you look at the example down here, we call top grade with S1 and S2, and then it returns true and false accordingly. However, if we call top grade with S1, okay, that should be actually S2 here. So let's just change it immediately. This should be S2. If you call top grade with S2 and pass on a different threshold, it will override the default. And then we have something that is interesting, but you should maybe avoid in general because it leads to a lot of confusion. You can have functions being nested within other functions. Okay, and what that means is that the scoping of variables and the scoping of the function is weird to understand, but it's within this function scope. So if I define a function +1 here, it's only available within the counter function. And within +1, I can use all the variables that are available also in the outer function counter. And for those of you who have heard about functional programming before, or things like higher order functions, this is what functions in JavaScript are. They're first-class citizens. They can be passed as parameters, and they can be returned by other functions. And then we have a certain thing called anonymous functions, and those are functions that don't have a name. And this is something that you usually use if you pass a function as a parameter somewhere. So those things are sometimes known as lambda expressions in other languages. So you've heard maybe that term before. And there's some syntactic sugar for this. It's called the fat arrow syntax. And here are a few examples. If you have one parameter and one expression in the body as return value, you can just leave out curly brackets and parentheses. It looks like this. If you have multiple parameters and one expression in the body, you have to delimit the parameters with parentheses. And then if you have multiple parameters, if you have multiple parameters and multiple expressions in the body, then you have parentheses on the parameter side and you have curly brackets on the statement body side. So on the right side, we have an example here. We can see that we have two objects here, S1 and S2. In this case, they only define grades. And we have this variable called GPA list. And there are two functions I'm showing you here that are very common in functional programming, map and filter. What map does is it takes a function and applies this function to all the elements in the list. So in this case, what happens is I take this function assign GPA and what it does is it just assigns a new variable to that object in this case, and then I go over the list of students and assign. So the original object gets a new key, namely GPA, based on this function. And then there's another function I want to show you, a filter, and in this case I'm using the lambda syntax, the fat arrow syntax, where I'm passing the function within the parentheses. I say student, and then with the fat arrow I say the body is student GPA less than equals to 1.5. In this case, what that means is I'm going to filter everything that does not have evaluate true for this expression. And last but not least, I want to talk about functions as objects, because this is a way for JavaScript, even though it's not a pure object-oriented language, to allow something that is similar to what you know of objects and classes. So what you can do is you can have a function, and then the function has the this keyword, and with that you can basically define keys of an object, because functions in itself are represented as objects in JavaScript. We can say this number is equals to some value, and so on and so forth. You can again assign functions here also. And now, if you say new student, for instance, based on this function definition, this student function serves as a constructor for new objects. Okay. And now in ES6, in ECMAScript 6, there's some syntactic sugar that makes this look like actual classes. Okay, it's the same thing down below. So if you look at what this class structure produces, again, it's just the object that we've seen before, but it just looks more similar to an actual object-oriented language. And this is also something that you probably won't need within this course. I just want to mention it in general, that all objects in JavaScript have a prototype. And what the prototype type is it allows for your objects to have an underlying inheritance structure. So if you look at the examples down below, so everything inherits from this object prototype. That's like the core object that you have. And if you look at the array here, the second example, then students inherits from array.prototype, and array.prototype inherits from object prototype. So this is the prototype chain that's going on here. It just means that there's some object prototype that defines some key properties and functions on that object. And then as I introduce this new object array, it has its own prototype, but it inherits from the top one. And now, as the third example, as I introduce my own prototype through the function that I saw before, this becomes a new chain. Okay. And what people did in the past, specifically that was like the late 2000s, is something called monkey patching, because you can change this prototype after certain objects and prototype chains have already been established. So you can introduce new functions, or you can change existing functions within the whole world of JavaScript. And that led to a lot of confusion and issues within JavaScript. So that's something you probably shouldn't do, but just be aware that it's something that is possible if you want to debug certain things. Okay, and here we're going back a little bit to how to define variables, specifically when talking about scope. And what scope is, it defines where you can use certain definitions, specifically variables or functions. So let's say, and we're looking at variables specifically here, you can define variables with var, let, and const. Var is the old way of defining variables. Now, with more recent versions of JavaScript, I would urge you to use const as much as possible and let as much as possible. Const just means that you define a variable and assign a value immediately, and it never changes. It already sends a signal to the person reading the code that this is a variable that I'm just going to use later on, but it's not going to change over the course of time. So that's already a very powerful message you're sending to people reading the code. And if you look at the example to the right here, this is a function called GPA message, and it takes a student, and based on the GPA of a student, it just prints out a different message. Okay, so the message itself, if you look here, is let, because it's going to be different depending on the block I'm going into in the if. So it needs to change over time. But now the average GPA and the student GPA will stay the same. They're just here for the sake of comparing things, and later on for the sake of printing certain things. And now if you look at the first branch, the GPA difference is also a const here. It could also be a let, but what I want to say here is I don't want to use it again later on in a different scope. And I couldn't even if I do it like that. And so let and const have block scope. And block in JavaScript is every time you open a curly bracket, that's a block in JavaScript. And if you define a variable within that block, it only lives within that block. And then if you use var, var is function scope, meaning that if you declare the variable with var within a function, it's valid within the whole function. And the thing is, though, that if you have defined a global variable outside the function with var, or even without var, because global variables can be defined anywhere if you don't use a keyword to define them, then var could very well introduce this global variable into the function. So just be aware of those differences. Okay, and I think that's the last thing within the core language. There's this new thing in ECMAScript 6, but it's been around before in other libraries of JavaScript, is this concept of modules. And what modules do is they establish a namespace in a separate module file. And there's some rules for that, and the rules are very simple actually. You can have one module per file and one file per module. So you cannot spread out the module within different files, and one file cannot have multiple modules. That's it basically. And within a module, you export specific elements. So let's say you have a number of functions and variables that you want to deal with within the module, but you only want to expose a few of them. So let's have a look at the example here. You can say you have a function called GPA, and you only want to export that function. So what you can do is you can say export function GPA. You can use this export keyword to expose this function to the outside world. Similarly, you can just define the function before. Again, a typo here. This is not gap, this is GPA. And then you can say export GPA later on. So the export keyword just shows the outside world what this module has exposed and is available to other files. So in other modules, or even in your HTML, for instance, if you have a script type module, you can import those files by saying import, and then you use either star. If you use star, then you import everything that this module has to offer with a namespace. So if you say, in this example here, import star as student from some file, then you'll have to use the namespace student to call the function. However, if you only export the elements by name, you already know the names, you say import, then curly bracket, the exported element that you want, and then you can use it as is. On the right side here, we have a bit of a cheat sheet of what the possible things are that you can export and how you import them, just for you to look up later. Okay, so now we're actually done with the core constructs of JavaScript, and in the next part, I want to go into the common APIs you use when using JavaScript within a browser.